Hello everybody and welcome to this webinar. My name is Järvinen Vesa and today I will tell you about artificial intelligence in architecture, engineering and construction. At IABSE, I work as chair of Task Group 3.6, which have title AI in Structural Engineering. My main work is at IABSE Group, an engineering consulting engineering company, where I work as a senior vice president and partner, and my responsibility area there is civil engineering. During recent decades, my responsibility area has changed. I have been business and technology responsible in engineering, as well as technology responsible in construction and manufacturing business. I have also worked as expertise at the university, where I made my doctoral thesis. My latest graduation is Executive MBA, which emphasizes more business side. I have got some patents and project awards, and at the moment I'm chairing this AI task group in IABSE and program committee of International AI Conference, which will be held next spring. This presentation has been divided under 4 topics: understanding, people, data, and applying. First, about basic understanding of AI. Here's a picture of digital transformation in different phases of industries. So the digitalization passes us towards the next industrial revolution, towards the Industry 5.0, connected ecosystems. This is already penetrating trend. This is a society where smart machines empower humans and the digital innovations enhance the well-being of the mankind and the nature. Here you can see Gartner's hype cycle. Gartner is a global research and advisory firm. In this hype cycle, emerging technologies are presented to show the common pattern that arises with each new technology or other innovation. More to the left, more in the hype phase, the technologies, more to the right, more in the realization phase it is. All these technologies that are in the hype phase doesn't reach the realization phase. But if you look at these technologies, you can see that AI is very heavily presented there. AI can be classified to 4 different levels. With the idea that when the higher level of intelligence is achieved, also the capability of lower level is served. First one is mechanical, then comes analytical, thirdly intuitive, and finally empathic. So here's an example of mechanical intelligence. Humanoid robot were used in the customer service phases. So these are mechanical processes that don't require much creativity. Netflix is a good example of analytical intelligence, where it's tailors is offering for the users by using algorithms. For intuitive intelligence, Google's AlphaGo is a great example. It won all-time best player in this Go game in 2016. There's a document out of it in Netflix. Later version of this application, AlphaZero, didn't even need a human to train itself. It did it by itself. If you look at these statements about this AlphaGo, they are very interesting in that sense that you can see that even though AI here is created to mimic human intelligence, it can create the moves that no human would have done. For the highest level in empathic intelligence, there are not so many application solutions at the moment. Maybe the Sophie, the human-like AI robot, could be mentioned as one. The Saudi government awarded her citizenship in 2017. Maybe you have seen her. One could say her here, I think. Maybe you have seen her because Sophie is circling around the world in different exhibitions all the time. Mainly the solution that has been done at the moment are narrow AI solutions. So they are specialized on very specific problems. Some of those AI solutions are at the moment already using broad AI, so they are solving problem areas, but where we are heading is general AI, and it still takes some decades to reach that level. If you want to understand a little bit more about AI in general, this basic understanding of it, to get the basic understanding of it, so here's one course I can recommend. It's online free course. There are already over 430 students who have signed up for it. It's spread worldwide, and it will be soon available in all the EU languages, or official ones. When we talk about more complex AI, machine learning is involved there. And if you want to understand it a little bit better, here's one way to do it. Watch this little bit, this video that will last about 1 hour, record where Risto Siilasmaa, former head of Nokia board, will explain very simplified way what is machine learning. Machine learning is divided in 3 different areas. Most of the solutions utilize supervised learning. Second most used are unsupervised learning, and quite rare yet and most complex is reinforcement learning. For supervised learning, here's a couple of examples. So using regression to get continuous response, or classification to get categorical response. So if one has mapping problem or prediction is needed. Here, the important things to understand is that data is needed to be labeled. For unsupervised learning, no label variable are used to find similar groups. So here's an example of clustering. You have different input data, and you utilize a different kind of algorithms to cluster and find the patterns. And the most complex one, reinforcement learning, explained by 2 pictures. On the left, you can see how the AI is training itself to play the well-known game. On the right, you can see also neural networks that are used in the agent. So there is no history data needed. AI learns by trial and error. It generates data and learning pattern. Then about people. As I mentioned earlier, when we are building AI, we are trying to build human-like capabilities, like read and write, reasoning, see, feel and move, smell, taste, hear and speak. That's the story of AI. But another side of this story is people under transformation. Here are some numbers showing how big this transformation is. So according to this study, 37% of global jobs could be replaced by AI in 2030. Or, for example, 65% of children will work in a job that does not exist at the moment. So we are heading towards a very big change. One could think it's even bigger. Here is a CEO of IBM saying that it's 100% of jobs, industries and professions that will be changed. And here's very well put that it's a change management issue, not a technology issue. It's all about the people. This graph shows how automation and AI will change the skills needed in the work life. So blue circle is a current state, white circle is estimation of needed working hour in 2030, and columns are showing in the percent-wise what is the change. So as you can see, technological skills and social and emotional skills are needed in the future, also higher cognitive skills, while basic cognitive skills and especially physical and manual skills are needed less. This graph shows potential jobs at high risk of automation. There are three different waves. So algorithmic waves that we are living at the moment. Augmentation phase where we are soon heading, and autonomous waves that will be estimated to happen in mid-2030s. And if you look where the construction here is, it's very high up. So there's a huge potential jobs at high risk of automation. And if you think about, for example, structural engineering, which is more technical business, so you can see it's a lower down, but actually if you look at the colors of the columns, you can see that the change will happen there earlier. This figure here shows how technology change is different from organization change. So while technology change at an exponential rate, organization change at a logarithmic rate. So this change management issue that was mentioned here already earlier. So people responsible about these changes should by and by think about which route we are heading. We cannot follow all the technological routes because change is so much quicker than the organization's own capability to change. So one need to select the direction and thus by and by narrow the gap between technology change and organizational change. And that doesn't happen only once. So what is needed is constant reinvention in the organizations, as well-known Alex Osterwalder here put it. Then about the data. So the development of AI has gone through cycles of booms and busts, but never earlier we have had such a high and accelerating data growth as this picture shows. And when we combine this with the fact that the rise in computing power has finally made the technology powerful enough to this all enables the promise of AI this time. So this is now the boom situation, and at the moment we think it won't be this time. It will hit through, hit the whole home run. Here are places where you can find the data: supplier interactions, physical assets and sensors, customer interactions, third-party sources, employees, and customer assets, depending on your business. When you have the data, you can have different kind of strategies how to profit from it. You can keep the data by yourself, use it internally, or turn it into advanced products and services. Or you can share the data with others. Sell it or give it away for free, for example, to strengthen customer ties. And when you have the data, it can be turned into knowledge by using a range of tools. Machine learning and neural networks, as mentioned earlier, NLP, machine visions, or data visualizations tools. Basic idea that you have to have input data, you are doing processing by utilizing AI, and then you get the outputs. Then about deploying AI and what it means in AEC. Here's a picture of megatrend matrix. And if you look top right corner, you can see the urbanization is up there. By 2015, over 80% of the population in developed countries is expected to live in the cities. And if you think about developing world, the estimation is that 60% of the population is living in the cities. So considering construction business, built environment, there is a huge change happening. And if we think about transformational shifts at the moment, this is from the same survey as the earlier megatrend matrix. You can see most of those links to our field of business. like 3D printing, circular economy, robotics, sharing economy, sensoring, big data, smart cities, connected living. And I would like to focus for the smart cities because that's something that enables a smooth transition to the urbanization. And there AI plays a key role. For example, in the smart park, smart mobility, smart grid, adaptive signal control, waste management, and so on. And when we talk about smart city, digital twins of the buildings are linked to there. They create data, they use data, and they feed smart city. And smart city creates data, and so on. So this is like a virtuous circle. So what is digital twin? Here is explained more detail. So it's the combination of the canvas with the integrated inherited understanding of our existing built assets and how they interact with the previous and future generation. So there is a physical asset and digital equivalent, and there's a connection and where information is enhanced. This link has to be living, otherwise you create the zombie. According to International Data Corporation, by 2021, half of large industrial public companies will use digital twins. And Gartner actually states that organizations who are using it gets 10 to 20% improvement in effectiveness. Here's a picture of future of construction. If you look through those things that I mentioned there, you can easily see that data is involved in all of those. And when the data is involved, then it means that AI can also be utilized. Actually, according to McKinsey report, construction firms could boost their productivity by as much 15% through real-time analysis of data. Here are some existing examples how AI are used from well-known big software company. Generative design example, when an Autodesk team in Toronto moved into a new building, it was designed by utilizing AI. So there's a picture where from left to right, each plan is overlaid with a simulation. First adjacent preference, then work style, bus, productivity, daylight, and view to the outside. Risk mitigation example. So, for example, using AI, especially construction language analysis, it's possible to automatically assign priority to issues. The algorithms are able to understand and predict complex things like whether an issue would cause a potential water infiltration if not addressed. And then safety example, where this picture is from an application that automatically scans all safety issues on a job site and attach to them, indicating whether it could lead to a potential fatality. An example from another company, which is well-known manufacturing and software company, Trimble. So first, prevent cost overruns, where AI neural networks are used on projects to predict cost overruns based on factors such as project size, contract type, and the competence level of project managers. Then using AI for better design through generative design, risk mitigation, those were already mentioned in the earlier slide, project planning. For example, the robots can autonomously capture 3D scans of construction sites and feed the data into a deep neural network that classifies how far along different sub-projects are. If you think about the productivity at job sites, you could use self-driving construction machinery for the repetitive task. If you think about construction safety, you could use algorithms to analyze the photos and so on. Actually, that was also already mentioned in the earlier slides. You could use AI to address labor shortages. For the off-site construction, you could use autonomous robots using AI to piece together components of a building If we think about construction site, that's a place where you can collect a huge amount of data. So there's a business potential that we don't yet even know all the possibilities that is involved there. So that's very interesting. Or when you think about service life building, post-construction phase, then again you collect a lot of data, as mentioned when we were discussing about digital twins. Here's an example from structural engineering side, how the design has been evaluated. We have moved from handmade drawings to CAD drawings, then to BIM models some decades ago. Now we are using parametric design or algorithmic aided design to make it more effective, to make it possible to optimize more, and self-learning algorithms is in the next phase where machine learning is utilized. Example of the current status is, for example, in that link where the parking hall design is presented. And here are some examples about construction sites, how to collect the data and how to compare the existing situation to what has been designed. And that Boston Dynamic robot spot dog there actually will be also in this next year spring AI in AEC conference in place. So if you want to see the dog, you can come there and meet that robot. With the smart buildings, we have totally new metrics we are using, like wellness, productivity, collaboration, occupancy, smart spaces, and location services. There's a link for Ireland's smartest building video, which is very interesting. Here's listed some example of properties of smart buildings. It can optimize energy usage based on occupancy or energy price. You have machines there, they need refills, you can use AI there. You can use occupancy information when you think about the cleaning to optimize that one. You can visualize different kind of routes for people, vehicles, and so on. And of course, nowadays, it's very important to think energy-wise also. So renewable energy is an important part of smart building to get to utilize it so that the net energy usage is at the minimum, or even so that building creates more energy than it consumes. When we think about the AI, we should not focus only what happens inside AEC. We should think and look around, look what happens in different business sectors. Here's McKinsey report that highlights some of the possibilities that could be used in AEC or are already used, but not as heavily as there's potentiality. So transportation route optimization could be used for project planning and scheduling, as it has potential to assess endless combination alternatives based on similar projects, optimizing the best path. Pharmaceutical predictive AI solution, which lower R&D cost in pharmaceutical side, could be utilized to forecast project risk, constructability, and the structural stability, and so on. Retail supply chain optimization could be used for projects which are using off-site construction for large quantities of materials. And 3D printing and construction, 3D printing, there's and modularization that are at the moment used, but there are lots of room to utilize machine learning more heavily. And image recognition could be utilized to compare final products against initial designs, or train an unsafe behavior detection algorithm to identify safety risks, and so on. Things that has been already mentioned, but they are only lightly used at the moment, and there are a lot of room to develop them further. If you want to learn more about AI in AEC, please join the conference next spring. Registration is already open, and you can also send abstracts to propose the presentation there. If you think you are too late at the moment, don't worry. Only 1 out of 7 large companies have deployed AI so far. There are even companies who have no interest for it. I hope that after this presentation, you at least are thinking, what is your schedule to deploy AI? At the moment, the focus is more building on the foundation, doing different kind of piloting. But it's now moving towards data science. So focus will be more on value creation out of data and AI. So this is a moment where you can still jump on to this movement, and you are not too late, but if you still wait several years, maybe the train has gone already. Now, how to do it? Here are steps that we have been used in our company, for example. First, business responsible people should have the basic understanding of AI. It's not enough that technology people knows it, because you have to identify also business opportunities. You have to understand the demand, not only have the supply, internal supply with the technology capabilities. To have it, read book, watch training videos, like mentioned in this presentation, or attend the courses. There were also some online course example in this presentation. Then you have to train internal technology AI experts, or recruit or use external experts to ensure the technology capabilities. But at least purchasing know-how is needed, as mentioned in the bullet point 1. So you need both, but you cannot only say to the technological guys, please do it. Both business personality and technology organization has to understand what is AI. Then you have to understand data. It's a lifeblood of AI. Collect, store, and process it. Investigate what data you have and start collecting is the first phase. And then link it to the business opportunities. And finally, start applying. First internally for improved quality and efficiency, and in next stage externally for improved competitiveness. And remember, this is not something that happens, you do only once. So the world outside is changing all the time. And if its rate exceeds the rate of the change inside your organization, the end is near. So you have to run all the time. Focus on the getting reinvestment capabilities into your organization. So I hope this short presentation helped to clarify what is AI and what it means in our field of business in built environment. If you want to learn more, please join the conference next spring. And if you want to ask some more questions or send some comments, or you want to know a little bit more about conference, then there's my contact information below. Thanks for this opportunity to share my thoughts with you. Have a nice summer.